Welcome back again. This is the second session of probability where we start our theory, probability distribution chapter. Right? It's the same thing that we did in 10th, probability only. Only the name is appended with distribution. Why distribution? Because here we deal probability in more general way. Probability attached to an outcome or range of outcomes. So, for example, if X is associated to outcome of an experiment, then generally we found out probability of an event A. So here we say probability of getting an outcome as A or probability of getting outcome as between B to C. So probability of X lying between B to C, right? B less than X less than C, or probability of X being greater than equal to D, or probability of X less than equal to E, or their union or intersection or combinations like that, etc. So all these things are covered under probability distribution. Right? If you don't have this question bank, it is available on the Google Classroom, right, of the same course code which I was told you earlier. So with all possible outcomes, the probability is distributed. So probability distribution. Right? Look at the first example. It reads, find probability distribution on the outcomes of throwing of two dice. The two dice are thrown and the outcomes are likely to be 2 to 12. Right? 2 to 12 are the possible outcomes. We cover everything. So here is the how we deal it. Two dice outcomes are 2, 3, 4, 5, 6, 7, 8, 11 and 12, right? Nothing beyond. Now, what is the sample space or universal set? N of u. First die has 6 outcomes, second die has 6 outcomes. So both together or one after the other can give us 36 outcomes. Right? This is from the fundamental principle of counting or multiplication theorem. Well, now look at this. 2 is a possible outcome. So for x is equal to 2, what are the different ways in which we can get 2? There is only one way, 1 comma 1, right? So only one way. The probability of outcome getting 2 is equal to 1, that is the event A is possible in one way only, upon the sample space 36, right? Now look at how to get outcome as 3. There are two ways, 1 comma 2 and 2 comma 1, right? So probability of x is equal to 3 is 2 upon 36. It's 2 upon 36, 1 upon 18. Now think of probability outcome to be 4. How is that possible? It's not just 2 comma 2 but 1 comma 3, uska ulta 3 comma 1 and 2 comma 2. So in total there are 3 ways. So probability of x equal to 4 is 3 upon 36, that is 1 upon 12. Like that you have to try for others also up to x is equal to 12. Well, I am doing the next one is going to be the biggest one. So I am doing x is equal to 7. So what are the ways in which 7 can be the outcome? 1 comma 6, 6 comma 1. 1 की जगह पे 2 आएगा तो 2 comma 5 and 5 comma 2. Then 2 की जगह पे 3 आएगा तो 3 comma 4 and 4 comma 3. So in total we found out 6 ways. Probability of x equal to 7 is equal to 6 upon 36. So that is 1 by 6. So that's how we have the answer as I have given full table over there. Right? With the question, answer to the question, I have given you full table. Right? So you can find out the remaining ones. Let us go to example number 2. This is a bit different, it will make you think. 3 bad mangoes got mixed with 7 good. Find the probability distribution on the number of bad mangoes. If 4 mangoes are drawn at random without replacement, 3 mangoes got mixed up with 7 mangoes. So in total we have 10 mangoes. The sample space is of 10, right? But we are drawing 4 mangoes from the set of 10. So what do we do? So number of bad mangoes. What is the possibility? It can be 0, it can be 1, 2 or 3. Even though we are drawing 4 mangoes, we can't have 4 bad mangoes. Why? There are only 3 now. The max is possible is 3. Right? So we start first the sample space. तो 10 में से 4 मैंगोज निकाले जा रहे हैं. Permutation or combination? Is order important or it's just a group being formed? It's a group being formed, right? So combinations. So the sample space n of u or n of s is going to be 10C4, right? So for 0 bad mangoes, for x equal to 0, all good mangoes, right, are drawn. So how is that possible? 4 के 4 अच्छे आम निकले. कहाँ से आएंगे? 7 में से आएंगे. तो 7C4 upon 10C4. You can calculate. It's 1/6. Now for x equal to 1, one bad mango I am interested in. So I am having 3 good mangoes and 1 bad mangoes. So 3 good mangoes are going to come from the 7 good mangoes. 7C3 into 1 bad mango is going to come from the set of 3 bad mangoes. 3C1 upon 10C4. So the probability distribution for x is equal to 1 is 1/2. Right? Now for x is equal to 2, that is 2 good mangoes and 2 bad mangoes. Now you can guess what is it going to be. It's going to be 7C2 into 3C2 upon 10C4. Right? The sample space remains the same, 10C4. Right? You can find out the answers. I will show you the answers in case you don't have the question bank. And that will be our last sum for the day. Here is the table. Let's count of x is equal to 0, 1, 2, 3 bad mangoes, right? And the probability distribution is 1/6, 1/2, 3/10 and 1/30. So the remaining 2 you can try to find out. If you have any doubts, ask them on the WhatsApp group, but do study and ask. Thank you. Bye.